Every single day, millions of us get in our cars or hop on a bus and take part in this massive, coordinated dance we call a commute. But underneath all that chaos, there's a hidden logic, right? A set of invisible rules that's dictating every turn, every stoplight, and every single minute of your journey. So let's peel back the asphalt and see what's really going on under the hood.
Oh, you know exactly what I'm talking about. You're just sitting there, bumper to bumper, and it feels completely random, like total madness. You're looking around thinking, there has to be a better way, right? Is there any method to this?
Well, the answer is yes. There absolutely is a method. It's this incredibly complex system, almost like a language, written in asphalt and concrete, all designed to manage millions of us trying to get from A to B. And today, we're going to learn how to speak it.
Okay, so first things first, you have to understand that not all roads are created equal, not even close. They actually exist in this really deliberate structure, kind of like a ladder that you climb up and down every single day without even thinking about it.
And at the heart of this whole system is one core conflict. It's a constant battle between two big ideas. Mobility, that's our need to go fast and travel across the entire city, and accessibility, which is our need to, actually pull up to our front door or the local shop. And here's the thing. You can't have a perfect 10 in both at the same time. It's always a trade-off.
And this table, it shows that trade-off perfectly. Just think about your own commute. You probably start on a local street, right? Super slow, but you can get to every single house. Then you hang a right onto a collector's street, which, like the name says, collects all the traffic from the neighborhood. From there, you merge onto a sub-arterial. And finally, you hit the big one, the arterial road. Here, speed is everything. It's pure mobility, and you'll notice there's almost zero direct access to buildings. You've climbed the ladder. So, we've seen the big picture, this whole hierarchy of roads. But what are these things we drive on actually made of? Let's zoom way in and look at the anatomy of a single street. First up is a term you might have heard, right-of-way. Now, this isn't just the road itself. It's the entire strip of land that the city owns, from one person's property line all the way to the other. It includes the road, the sidewalks, the little green medians, and even the space for all the pipes and cables buried underground. It's the whole shebang.
Now, the part we actually drive on, that has its own special name, the carriageway. Simple enough, right? It's just the paved surface for all the vehicles. And here's a cool little detail. That carriageway is built using standard-sized blocks. According to the Indian Roads Congress, which kind of sets the rules for this stuff in India, the standard width for one single lane of traffic is 3.5 meters. Pretty much every multi-lane road you drive on is just a multiple of that number. It's the fundamental building block.
All right, have you ever noticed that roads aren't perfectly flat? They've always got this slight hump in the middle? Well, that's called camber, and it's basically the road's own built-in raincoat. It's a super simple but brilliant bit of engineering that uses gravity to make sure rainwater just flows off to the sides instead of turning the middle of the road into a giant puddle.
Okay, so we've got these carefully designed roads. We know how wide their lanes are. They even have their own drainage systems. But what happens when these paths have to cross? Well, that brings us to the real art form of traffic management, the intersection, where worlds collide. Generally, there are two ways you can handle this. You've got your at-grade intersections, where roads cross each other on the same level. Think of any normal traffic light or a roundabout. But when you really need to keep traffic moving, you use a grade separator. That's where roads cross at different levels. Like a flyover that goes over a busy junction or an underpass that goes under it. So why on earth do we build these massive, super expensive flyovers? It all comes back to that very first concept we talked about, mobility. The whole point of a grade separator is to let the traffic on that big arterial road just keep flowing, no interruptions. By literally lifting one road over the other, you get rid of all of the potential conflict points. It's all about prioritizing speed. So we have the roads, we have the intersections, but how do we actually know if it's all working? How do you give the traffic system a grade on its performance? Well, city planners use something called level of service, or just LOS. The easiest way to think about it is like a report card for the road. It gets a grade from A to F, and it's not just about how many cars are there, it's about how it actually feels to drive on it. So level of service A is the dream, right? An open road, you can go the speed limit, total free flow. Then you have LOSC. This is actually what most city planners are aiming for. The traffic is moving, it's stable, but your speed is definitely being controlled by everyone else around you. And then you have LOSF. That's total failure, gridlock. The system has just completely broken down. Okay, you've been absorbing all this info, so let's see what's stuck. It's time for a quick pop quiz. You ready?
Question 1. In that traffic ladder we talked about, which road gives you the highest mobility but the lowest accessibility? Is it A, B, or C?
And the answer is C, Arterial Road. These are the big highways of the city, built for speed and getting you across town, not for popping into the corner store.
All right, question number 2. What do you call that slight hump on the road that's designed to drain away all the rainwater?
That's right. The answer is C, camber. Remember? It's the road's very own built-in raincoat. You got it.
So we'll leave you with this final thought. The next time you're out there driving your commute, whether you're cruising along or stuck in a jam, are you just going to see a boring stretch of asphalt? Or are you going to see the ladder, the trade-offs, and this incredible invisible system that is actively shaping every single second of your journey?